Back in. I just jump through 6.2 to where we kind of left off really quick, so that way we're kind of everybody's on the same page. Remember we went through 6.1 that talked about normal distributions, which is basically a normal distribution is defined by its mean, it's symmetrical, it has an x-axis asymptote. Pretty straightforward. I showed you the whys of why it works. You also got to see Plinko and understand Galton board, so that always helps out. Jumping back through 6.2, jumping right in here. Notice I gave you that. Okay, that is just the function, just not any other function that you've seen before in any other college algebra class. It's just really ugly. Okay, but if you wanted to make something into a normal distribution, like if you had a whole bunch of data, that's what the function you would plug it into. And it would create the normal distribution for you. But as you can probably tell from the last lesson, normal distributions kind of happen organically, just by things, just by nature in and of itself. Not all the time. Okay. And then we've now gone with a standard normal distribution. Remember, we were standardizing things. Okay. So everything stayed the same except for, if you will notice, our mean now is no longer just a mean that we have. It's defined by the mean is always going to equal 0. And we have that standard distribution of 1. Everything else is the same. Okay. Area under the curve is 1. We still got that asymptote on the x-axis. Okay. It's still bell-shaped. It's still symmetric. Okay. That is going to become very important, especially in this lesson. Whenever I skip forward here in just a second, you're going to see why that symmetry is going to help you out a lot. Especially for those of you using a TI-83 calculator. If you're using a TI-83, and the notes I did download has some notes for TI-83 work. So that'll kind of help out a little bit. It's nothing major, but there is a certain little quirk that TI-83s do. If you're using a TI-84, you should be all right. Okay. And either way, you're going to be okay. Continue on. Notice you got the z-score. I told you how important that was going to be. Notice on this side, it's defined by some mean that we've got. Okay. And I showed it here to you shortly. Okay. And then we're going to standardize it. Notice on this one right here, we have a mean of 25. One standard deviation, which how much information or data is contained within one standard deviation? What? 68%. Very good, 68%. We know that 68% is within one standard deviation. Okay, and then they give us a data point right here. Okay, of 27, which is not at one standard deviation. So remember, whenever we worked out through all these, we did figure out that this one, hey, this would go to a standard deviation of 1. This did go to a -1. I don't know if we worked out that one. This one did go to a 0. Okay. And then when you're doing z-scores, remember, you're going to round to the nearest hundredth. So we got 0.625 on this one. But remember, this becomes 0.63. Okay. Thinking about that and what all that means, let's kind of continue on with our explanation here. And you're going to start seeing me write things the same way I would have written them if I was in a calculus class. Okay. But it's also the same way your calculator is going to be asking you for some information shortly. The 19th century normal distribution tables were created using that formula that I just gave you. People without calculators integrated that. Okay. Integrate, all that is a fancy word for taking the area of something. Okay. Taking the area over some complex curve, we'll put it that way, some complex function. Okay. Well, the nice thing is you do have tables. And if you did bring your book today, you'll notice, and I brought mine today. You have tables right here at the very front of your book. Okay. Now, some people like using these tables more than they like using their calculator. And that is totally fine because sometimes the tables are faster. Okay. For your final, I do provide you the table. Okay. They'll be given to you in a little packet along with a lot of formulas that I do not list what those formulas do. Okay. That's just kind of a heads up as you learn these formulas. Now, there's formulas that your calculator does for you. Okay. And so maybe that formula kind of go, oh, yeah, this is the button I need to push. Okay. But you do get a listing of formulas. Continuing on. Notice you're gonna have to read the desired to find the area under the curve, because remember, the area under a normal curve is always 1. But now we standardized it, okay? So if you have information, you are gonna have to standardize it if you are going to use the table, okay? You can't use the regular means and everything, or the means and the standard deviations you're gonna get. Everything has to be standardized, okay? And then we'll use the table. So if you had this one right here, once upon a time, that's the formula you would have to use, okay? Before, like I said, some really nice 19th century gentleman over candlelight decided to work out all the tables that you see here in your book, okay? But let's pretend that we were gonna do this. Some of you are gonna go into calculus. I'm not gonna integrate this thing because that's gonna involve a level of calculus even I don't wanna do right now, okay? But I do want you to see something. If I said to you, now you know this for a fact, that the area between here and here is 68%. You know this. But now notice, what if I took this and said, well, let's say I'm integrating. If I said this is my lower bound and this is my upper bound, okay? Lower bound meaning I can't go any lower than that. Upper bound meaning that's where I'm going to stop. That's exactly what that formula is telling you. It said, hey, you've got some number that you cannot go lower than, and you've got some number that you cannot go higher than. Also, just looking through that formula, you can see that in that formula, there is a data value right here of X that we could put in there if we chose to, right? And when you decide to integrate this, you would actually get 68%. You'd actually get 0.6800, but it would work for you. Okay? I say that because I want you to remember that where I'm saying the word upper and lower a lot. You're going to need that. Okay? And like I said, good news is, like I showed you, when you have one like this one, you can say, hey, let's turn all of this, let's standardize everything, come in here. And then we know that it goes to 0.63, excuse me, and let's see how that works. Well, remember in the last class, I also showed you how to use your table. Now, the area under this curve is what? The whole curve. 1. Remember that. The area under the whole curve is 1. Whatever data you have, we don't know that it looks like this exactly. It's probably not. But we do know it's going to approximate it really, really close. But I also want you to remember right now, we are still dealing with population. A lot of our numbers are going to be a lot more exact right now. Okay? Until we get to 6.5. Okay? Now, obviously, hopefully everybody can look at this and go, well, obviously right here, where that 1.37 is, that doesn't equal 1. Okay? That is some sort of area from here back. There is some amount of this normal curve that has been colored in. Okay? And we need to find out what percent. Okay? And this is exactly where you would have started using back in the day that other formula for integration, but luckily for us, we have calculators and tables. Okay? Well, what I do want you to notice is, what direction is this thing going in this direction? Is this ever going to equal 0? No. What does asymptotic mean?
Touches.
Never touches. It's never going to touch. Okay? So can we all agree that if you were back in intermediate algebra and you were learning how to graph on a real number line, if you were going to the left, what direction are you headed? Very good. So could we not say that if I was going to bound this, like I showed you earlier, I could say, hey, my lower bound is going to be what? Negative infinity. But my upper bound would be what? Exactly. Keep that in mind. Okay? Using the table, I can pull this up and go, okay, well, let's use the table. There's what your table looks like on the right-hand side of your page, because on the left-hand side of your book, it's going to give you negative numbers. Notice here, That's your z-score up to the tenths. Over here would be the hundredths. So if we started looking for 1.37, notice, using my amazing PowerPoint skills, you got 1.3, then you got 0.7. You add those together, you get 1.37. We find out where those intersect. And they intersect right there at 0.9147. What is that saying? What does that mean? And I want you to think about it because on your final, I actually ask you those exact words. When you give me a number, you don't just get, you just don't get an answer. You have to tell me, what does that mean? So you better start learning to conceptualize this now if you want full points on your final. Because remember, I told you day one, this is not like a normal math class. You need to walk out of this understanding stuff. Okay, so what is it saying? Yeah, very simply, it's saying from negative infinity up to that 1.37, 0.9147 or 91.47% of that curve has been filled in. Okay, that's exactly what that's saying. So if you had some data, you could say this data from here back represents 91.47% of whatever thing I'm studying, doing, whatever it is you're sampling. That can help you see it a little bit better now. How hard is the table? Okay, not hard. It gets a little easier later on. Notice now, and this is where we left off, because I want to make sure that we didn't get too far, too deep into the woods. But I need you to start like really taking the time now to go, okay, we're literally about to be in statistics class now. Okay. Like we've been doing population, the math has been simple, and the math is going to stay simple. It's the conceptualization that's about to get hard. Okay. And I don't want you to get lost. Okay. Notice when we standardize a normal distribution, what's really nice about it is they're symmetrical. Why does that matter? If you're looking at your table where you forget how to use your calculator, which does happen on the final, your table only takes area to the left. Okay, so if I asked you for this z-score right here, we're going to pretend like this is a z-score of, let's use the same number, 1.37. Well, we know what the area is, right? For what? This direction. And that's 0.9147. But that's not the area they're showing. Is it? I'm wanting that area. So you gotta be careful. Okay, like on this one, that's how come I've been talking about and why you learned about in 4.2, learned about the complement. You could come here and go, well, how about 1 minus? And that would give us that area. But also notice, if it's symmetrical, instead of doing any math at all, couldn't I come over here and look up at negative 1.37? And that would be the same area here as the same area right there. Because they're symmetrical. So you got to kind of remember things like that. Now, like I said, there's a lot of ways to do this. Okay, when you're trying to look up z-scores. Which are going to be important. From moving here on out, we're going to use z-scores like crazy. Okay? Because z-scores are the data that we're studying. It's a stopping place. It's a bounded area. You got a lower bound, you got an upper bound. We need to remember that. So, as I showed you here, I'll bring it up a little better. Look at this one right here. Notice 1.37. Well, what this is saying is, hey, if you put in that negative 1.37, this is the number you're going to get. Remember that negative 1.37 is right here. But if I was looking for this area right here, like all the shade area, couldn't I take this number and do 1 minus 0.0853? And when you do that, you're going to get these 0.0853. was it 9,147. Once again, a lot of ways to play with the complement on this, okay? That's gonna be especially important for you people using a TI-83. Okay? You people using a TI-84, congratulations. Your calculator will do right side, left side, and in between. Okay? TI-83s only do left side and in between. Okay? It won't do the other way. So you gotta be careful about that. Okay? Let's look at one. Find the area under the standard normal curve between Z1 is equal to negative 1.68 and Z2 is equal to 2. Okay, who didn't bring their books today? Next time you don't bring your books, we're taking 5 points off your grade for the day. Bring your books. Okay, you are going to need them now. Okay. Find me, those of you who have your book, find me the Z-score for one of you, find me the negative 1.68, and one of you find me the Z-score for 2. Because you do need to have this ability, because I want to show you on a final. Now, as you're looking that up, I need to emphasize something very important here. Start drawing. Okay, this is gonna get conceptually hard. I don't need to see Michelangelo style work. Start giving yourself sketches. It's gonna help you, even when you're using your calculator. It's going to help you use your calculator. I promise you, okay? Things are going to start getting a little bit weird, but the picture tells you everything you need to know. Okay, I promise you this. Okay. Notice what we're looking for here. This is the guy we're looking for. We're looking for a bounded area. Notice these tails here are not colored in. So doing a picture, I know, like I said, I'm looking for this right here. Very simple, right? Notice how hard I made that sketch. It's something just for me to look at. I know also that one of these Z-scores is 1.68. The other one is going to be a 2. What this is saying up top is this. And like I said, there's a few ways to do this one. It's actually kind of nice, okay? But this is just using your table right now, okay? Notice I can come here and say, hey, how about I take all of this curve here and just go to this 2? And I can take the area of all of that right there. But then I can do what? Subtract off this part right here of this negative 1.68. That's going to give me some other area. I can subtract off that. And that's going to give me that area right there. Okay? Does anybody have a Z-score for 2?
.9772.
Very good. How hard was it? Be honest, how hard was it to find? Very simple, right? I think the one thing to be careful of is looking at the 2. Make sure you look at the 0 at the top, right? Because if not, it's going to give you the wrong number. So yes, 0.9772. And then the area of negative 1.68.
0.0465.
Very good. And that's just some simple calculator work now. And then you can find out that the area left under that is going to be 0.9307. There's your answer. That's how much area under the curve is fitting right inside, right here. Which decimals are weird. So you can turn that into a percent. Hawks doesn't want it that way. I don't want it that way. But still, 93.07% of that area has been shaded. Okay, so if you actually had data of something, let's use you. Let's use all my stat classes. And I said, hey, how many of my students' grades fit between here and here? I go through, I standardize everything, which I don't really have to do. I'll show you that shortly. And I can say, hey, 93.7% of my students fit between here and here. Now, being that that's an exact percent, I could come in and have some other student go, hey, what's the probability that my grade falls between here and here? I go, oh, about 93.7%, 07%. That's what that's saying right there. Remember, this is still all probabilities, okay? A little bit more exacting probabilities, we're gonna get to fuzzy probabilities by 6.5, okay? Because if any of you remember the past election, did they say that Harris was gonna win by this exact amount and that's it? Or Trump was gonna win by this exact amount and that's it? No, they always did a what? Hey, Trump's ahead by this much, plus or minus. There's always that level of like, I don't know. Okay, which is what you'll be learning later on. You'll learn all about that, plus or minus. Let's look at another one. Notice on this one's got tails. They just want the tails. Unfortunately, it's not sitting at a very nice area. Okay, but now let's have a little bit of fun. Let's make it a little bit easier, okay? First off, I want to show you how to do this with your table. Notice it says here, find the area under the curve left, okay, of -2.50, which would be right here, -2.50, and to the right of 3. Which one of those would your table give you right now? Which is what?
Negative.
The negative. It'll give you the negative one. Because it says your table only gives you area to where? The left. Well, what about that area to the right? How am I gonna get it? What if I said, hey, you know what? You're not allowed to use your calculators on the final. You have to use the tables. And show me. How would you do it?
Same thing,
Huh?
same thing, because it's a measure.
Saying what though? What number would I find?
You would do -3.
Okay, you were very close. Yeah. Wouldn't the same thing, if I redrew this and said, hey, let's not even worry about him. We know that's gonna give us some area, it's right there, it's gonna be sitting on the table, isn't it? But since these normal curves are symmetrical, I could come in here and go, hey, how about -3? And I'll just look at the area to the left of that as well. Take what? Add both those areas, wouldn't I? Wouldn't that work nice? And that's exactly how you could do it. You could come in here and notice the z-score for, I'm just gonna kind of write them under here. The z-score for this one will be 0.0062 for the z1. Z sub 2 is going to be 0.0013. Notice very small areas. Don't you find it weird that something goes off to infinity yet has a finite area? Never thought of that. Add those two together, you're gonna end up getting 0.0075. Always round to 4 decimal places, because that's exactly what you're gonna be getting in your table. Now, hear me out. In about 3 seconds, I'm gonna show you, maybe a minute. I'm gonna show you how to use your calculator. Your calculator is gonna give you a slightly different answer, okay, than what it's on your table. Okay, one, it's gonna calculate to a lot further. Okay, so your rounding abilities needs to go through the roof, okay? Or you're gonna get a lot of red bars on Hawks. So remember, to round to 4 decimal places, we need to look where? To the 5th, okay? That's how it's gotta be. Now, sometimes when you round to the 5th from your calculator, it's not gonna match what's on your table. That's okay. Okay, you'll get a green bar, I promise you. Hawks does account for calculator use. The reason you're gonna get a larger number is because your calculator is calculating everything to these infinite, irrational numbers. Whereas Hawks didn't do that on the tables, they didn't do that. Okay, so just kind of be warned about that. All right, let's make this a little easier. How about we start using our calculators? So get out your calculators, and I'm gonna start once again. start drawing pictures, okay? Look at what it's trying to tell you. First off, why is he using a P? Probability, always remember that. These are probability distributions. Okay? In chapter 7, I'll get into distributions of why things do this, why things can become normally distributed no matter what. But right now, you just need to understand everything is normally distributed and we're dealing with probabilities. So if I was going to draw this first one here, I would look at it and go, okay, I've got a normal curve. Here's my mean. My z-score is 1.45, so that means I know I'm at least 1.5 standard deviations away from the mean. Like I said, your art doesn't have to be perfect, but it does help to make it as close as possible. You'll see why this becomes very important once again in the following chapters. But I can say, hey, it's roughly going to be right there. Now, am I taking the area to the right or to the left? To the left. One says what? Less than. So this could be from this number back. Are we good? Could you get to there? What would be a lower bound? Where is it going? Okay, remember that. Negative infinity. What would be my upper bound? 1.45. Very good. Yes, it does say less than, not equal to. You don't got to worry about that when doing a z-score like this, okay? So don't worry about that right now. Get out your calculators. I'm going to show the TI-83 real fast, how to do this. I'm going to write down how to do it, and then I'm going to show you TI-84s, okay? They're almost verbatim, exactly the same thing. It's just TI-83's got to put things inside of a parenthesis. You guys are going to have a way to just put it into like a little list. Okay, so you get your calculator, everybody's going to hit their second key, and then they're going to go to the distribution key. Remember when we were using that one? Okay, but now we're going to be, and you need to remember this button. You're going to use it probably more than any other button we use from here on out. Okay, normal PDF. It should be number 3, 4, something like that. Is it 3? 2? Oh, that's right, because normal PDF is your first. Yes. Yes. Would everybody rate, before you click on that, go back to that button. Does everybody here have a button called inverse norm? INV norm. Does anybody not have that on their calculator? Gonna be very happy later on then. Good job. Some people don't have it, and I gotta go through a whole little thing on showing you how to do something. The good thing is, y'all don't have to worry about it. We'll get to that later. That's kind of while we're there. All right, TI-83 people, you're gonna probably, after you hit normal CDF, you're gonna see a normal CDF and then a parenthesis. Okay, here's how it works for you. You put in a lower bound first, comma, upper, comma, and then it's gonna be asking you for the mean and then the standard deviation. And then you need to make sure to close off the parenthesis, okay? Now, here's a question for every single one of you. What would the mean be? 0. What would the standard deviation be? 1. When you're using something that's standardized, your mean and mean are always 0 and 1. Okay. Now that can change later on. You'll see that when we start doing like more specific word problems, that'll change. Okay. For the rest of you, TI-83, it's going to look like this. Lower, upper. Then they give you a symbol for mean and a symbol for it. And then they probably give you this. Tails. Does it give you the tails on there? It doesn't. If it doesn't give you tails, okay, everything's going to be to the left for you. So just kind of be ready for that, okay? Do some of y'all have, some of y'all, if you're using a TI-84 plus, it'll give you left, right tails. Okay, or center as well. Okay. All right, let me give you a little hint. You can't put infinities in your calculator. Okay, so here's what I do. Okay, depends on where I'm going. Okay, so if I am looking for infinity, this is what I put. One e to the 99. To get to this button right here. Look at your number 7 key, look up, it should be a comma. If you look right above that comma, like after you hit the shift key, it says EE. That's your scientific notation button. Okay, so when you put 1 e to the 99, you're doing a 1 with 99 zeros. Okay, so what you've done is basically create a bound that's infinitely far out there. Okay, that's all you've done. Well, if you want to do a negative infinity, it's the same thing, you just hit negative 1 e to the 99. Okay, so notice on this one, what are we going to do? Negative 1 e to the 99 is going to be my lower bound. Some calculators work if you put in a really large number, but it has to be a really large number there, okay? So what would be my upper bound for this one? Yeah, 1.45. And then, of course, my mean is going to be 0, my standard deviation of 1, and then you would hit calculate. And immediately it should give you, and I'll put it right here, waviness because it's not exactly equal, 0.9265. Did everybody get 9265? There you go. And that's how it's done. Well, let's look at the other one. Notice here you've got this z is greater than negative 1.37. And it might let you try using the bounds on this one because I didn't have anybody have any problems with this one yesterday. So see if this works for you. Watch how we're going to do it. Let me do some erasing here real fast if you don't mind. So that way we have plenty of room. I'm not going to change my little information over here for the calculator so that we can kind of keep seeing it, okay? So notice here, my picture would look a little different, wouldn't it?
Yeah.
I've got this z-score, but it's all the way over here. But this could be a negative 1.37. But now where's my bounds? Which way is my shading? Yeah. It's going this way. So test it out on your bounds. What would be my lower bound now? Exactly, negative 1.37. Please make sure you're using your negative button, not your subtraction key. Your upper is going to be the what?
1.
Yeah, one very large number, which is why I put that 1 e to the 99. Everything else can just stay the same. You click your button on that one, it should give you this 0.9147. If you didn't get that, please let me know. And if you are getting it and you're sitting next to somebody that doesn't get it, please help them out. Okay, let's make sure we all are very good at using our calculators. We don't want to be lost on this. And I may have been mistaken over what your calculators do at this point. I've gotten so spoiled by my TI 94 plus one that I forget. But okay, so if it ever gets to a point that I'm doing something on a calculator, please reach out to me. You know, and we will figure it out together because everything I can do on my calculator, you can too. It's just sometimes you may have, depending on the calculator, you may have to do just like 1 or 2 extra steps, but I'll make sure that you're able to work it out. Do the next one. See if you can't figure it out. And then I'll play catch up. Draw a picture. Because the picture will help you see your bounds. Isn't that kind of the hardest part? Where is this thing bounded at? Sammy, did you raise your hand?
No, never mind.
You got it? Okay. While you're doing it, don't overthink your drawing, by the way. Okay, like I'm not grading your drawings. So. While you're working on this one, here in about 3 weeks. Trying to remember the dates, it's too many dates. You're gonna have your only paper homework project. Okay, you'll need to take it, do it, you can work together. You can work with friends, y'all can work as a group, doesn't matter, 'cause it's pretty extensive. It's about 12 questions, but it asks you to actually, you're doing an experiment. Okay, I give you, and then you get the choice. I give you, I think, a tennis question or a football. Forget. And I may add one more, but it's literally after we get closer to finals. And because we're actually closer than you think. When we come back, we only got 4 weeks left, well, 5 weeks left of class. Okay, you got about a week to do it. You can download it, I think, now, if you want to start looking at it, okay? But some of this will be on there. Okay, but you basically are going in there saying, hey, what is this thing telling you? What's happening in this experiment that this person is running? Okay, and as it gets closer, I'll explain it very carefully with you and stuff like that, but it's a nice little project. Yeah, I always draw my mean line, I'll be honest, because looking at those Z-scores, it kind of at least helped me where to put my numbers, right? Because I know 1.25 is probably gonna be right here. 2.31 is roughly right about there. Is that exact? Not anywhere, shape, or close. I don't care. But it does tell me this, I'm looking for that. And that is bounded at 1.25 and 2.31. So on this one, I won't be using any infinities. I have now bounded my area to 1.25 and 2.31. And hit calculate, and you should have gotten 0.0952. Everybody get that okay?
I have a question. So what I did it with the negative infinities, and I did like separate. So I did negative infinity with 1.25 as the upper, and then I did the.
So you came over here, you put a negative 1.25, right?
No. No.
Oh, you use negative infinities, negative, I'm sorry.
Yeah, I did
Yes, yes,
negative
yes.
infinity, yeah.
Okay,
And I
okay.
did both of them, and then I subtracted both the answers, and I got the C to D.
That's why it works, because it's
zero.
symmetrical, because you just found a geometric reason why it works, and that's totally fine. Yeah, now you did a lot more work doing it that way. Now notice, you could just put your bounds in.
Okay.
Try that way real fast and see if you get it that way, make sure you get, but that's a great way. What she did by doing more work, and I'm not making fun of her, is she's proving to herself, this works geometrically, and it has to, and that's a great thing to do. Because sometimes things aren't gonna be just easily bounded. I don't care if your calculator is showing it to you. You may have to do some little like algebraic gymnastics to get to the right answer sometimes. Okay, and it's good to know that you can do that. So, good job. Let me see here, we got. Trying to see, it's pretty much homework questions after that. Let me just kind of look through it real quick here. I'm gonna show you one. This one's very simple. I'm not gonna have, you can look at your notes on how to do that one right there. Let's not waste time on easy questions. Let's kind of go back to algebra class, yes.
You take a look to see if I'm doing it right.
Yes. On which one?
The second one.
The E, but it's not right.
So
Did you use your negative? It's actually key, use your negative key.
I mean, I'm.
Still.
Let me know that work.
all right.
Yes, remember, do not use your subtraction key, use your negative, your calculator is very picky about which is which. Cheap calculators use both. Our calculators, no, they go, you know, so it's okay, and I've done that before, trust me, you're not the first. Looking at this one very, very carefully, we're just gonna do some algebra real fast. I'm not gonna do the whole thing for you, but I am gonna help you kind of solve this algebraically. Notice they do give us a z-score here, where z is equal to x minus mu all over the standard deviation. But then they tell us, hey, you're not given mu, So you need to solve for mu. This is going back all the way to developmental math 2. Okay, but sometimes if you don't do it, you lose it. Okay, I didn't know you did this in college algebra too, I believe 1.4, 1.5 in college algebra. But notice here, let's go and start solving, okay? Notice you're dealing with a proportion. Anything equal to something else is a proportion, so we can come in here and say, hey, I'm gonna cross multiply that guy up because that's gonna remove the standard deviation from the bottom. That's gonna give me z times the standard deviation, which is going to leave me x minus mu. I have a positive x. How about we subtract x from both sides? That is now going to give me z times the standard deviation minus x, that canceled, is equal to negative mu. What am I dividing by now to get it by itself? Exactly. Let's divide this thing off by -1 off both sides. That cancels out the negative, and then you are left with mu is equal to the z times the standard deviation minus x, all divided by -1. And that's exactly how you would find anything. But that's kind of like, you should know how to do that, right? Everybody good with that? Now let's work this one. I want to show you something. Look at this one very carefully. First off, it's symmetrical. Is it right? Look at it carefully. They're giving me 2 standard deviations. Okay? But the reason I really want to work this one for you is it's kind of, well, there's one later on in this same homework example, but I want to show you something with this one. First off, if we draw our picture, okay, we should know it's going to look like this. Bless you. Thank you. I've got a standard here. I've got a standard, a z-score there. I know I've got my mu right here. We're going to say this is negative 1.69. Here's going to be a positive 1.69. And it's asking for the area where? In between or toward the tails? Toward the tail. You need to remember that word tails. Okay? Put that in the back of your brain real fast for me and just kind of say, I'm going to need this later on. Let me remember that. Okay? So we're looking for this right here. Now, I want to be honest with you. This one, very simple. Because can someone tell me a way easily to do this on their calculator without making it too hard? Look at it.
Find one,
Find one and then what?
so will be the same. It's symmetric.
They're symmetric. If I find one, they're symmetric, but that means what? So if I find one, I've only got the area of one of them. So what do I need to do?
Multiply by
Very good, multiply by 2. You find the area of 1, okay, which means I probably, let's be honest, if I want to make this easy on myself, you could do either one, really, couldn't you? I could come here and go, okay, I'm going to have a lower and upper. I know my means and my medians are going to be standardized because look at the z-scores we're using. So mean and standard are going to be 0 and 1. Pick whichever one you want. If you're going to do the negative z-score, could you agree that your lower bound would be a negative large number, negative infinity? If you use the other one, your lower would be the 1.69, right? And then what? Your upper would be positive infinity. So you get to make the decision on that. That's why I'm not going to write it down here. When you do the 1, though, do you get this right here? 0.0456.
I got a 0.455.
0.455. What's the next number?
1.
Zero point zero.
Yeah.
0.0455. There you go. But then what do I gotta do? Multiply it by 2, because you're looking at 2 different areas, 2 separate tails. And then once you do this, you're going to get 0.0910. Well, that's all well and good, especially when they're symmetrical. What if they're not?
And you have to find.
Hmm?
Okay.
You could do that, that would work, that would work very, very well. You wanna see a quicker way? Look at it carefully, let me change the color here if you don't mind.
Did you find the center and then take the complement?
Very good. Look at what he just said here. Hey, what is the area of the tails? 0.0910, right? Well, wouldn't the complement be that? So couldn't I, if I really, really wanted to, couldn't I just come here and go, well, how about I do this? Negative 1.69, 1.69, whatever number I get, and then do 1 minus that number. And now you have found what that is not. That's the importance of the complements. That's why we like them, especially that's why we like this thing being symmetrical. Okay, and if you do that, you end up getting 0.9090, and oh, wow, look. You get exactly the same thing again. Okay, so it's one of those like nice little helpful tricks. Yes, by all means, calculate one area, calculate another area, add them together. It works. Do it if you like doing it. Okay. Reason I say that is if you look at another homework example, look at this one right here. Look what it says there. The area to the left of negative 1.49 and the area to the right of 1.11. Those are no longer sitting in a place where you can find 1 multiplied by 2. They are two totally separate types of areas. But you could also bound them in, find the area in between, and then do 1 minus all that, and that'll give you the rest. Or calculate them separately. It's really up to you. I think in your homework, I did that. If you actually, the lecture notes that I put down there yesterday, if you look at that, I actually show you to do it that way. Okay? You don't have to. You do what you like. How do we feel about finding z-scores and finding the area? Not horrible, is it? Okay. It is a skill you need to keep remembering. You're going to use it all over the place. From this day on, we're going to keep using it. Okay? Let's jump into 6.3. 6.3 has no, other than the lecture video that I will be posting tomorrow from this week, there's no lesson video for this one. Okay? It's literally going to be word problems. And I covered 3 of them. Okay, and we'll go over just a couple real quick and I'll leave you one. Notice this one right here. Suppose that a mean calorie intake is 2,050 calories per day with a standard deviation of 175 calories. Assume that calorie intakes follow a normal distribution. Okay. And then it says, hey, you're gonna need to find some stuff. Well, that's all fine. Does it change anything on us though? That doesn't look like a 0 and 1, does it? That's okay. You know what you do when you do your calculator work? Change your mean and your standard deviation to match the question. And it'll work it out for you. It'll still give you all the data you need. You don't have to standardize everything. If you want to use the table in your book, you will have to standardize everything. Okay, you'll have to standardize the mean, you'll have to standardize the standard deviation. Okay, so having said that, let's do number A. A says this, find the probability that a peer in your class consumes more than 1,800 calories per day. Okay, looking at this real quickly, if I just draw myself a quickie little graph here, I know my mean is at 2050. And it says, hey, I know 1,800 is going to be roughly right about there. Am I going to be looking to the area to the left or to the right? To the right. More than. Look for those words, more than. And so I'm going to calculate this to infinity. Do that on your calculator very, very quickly. Making sure, or ensuring, proper grammar, ensuring that you are going to put the mean now at 2050 and the standard deviation at 175, but you have lower and upper bounds now. You have a lower bound of 1800, you have an upper bound of a very, very large number, or your 1e to the 99. And the probability you should get is going to be 0.923. What is that saying? Remember, I'm going to ask you on your final. I'm going to ask you on this project coming up. What is that saying?
30% probability that your consumes more than 1,800.
Yeah. If I just randomly walked around and just grabbed somebody out of the population and then monitored their calories for one day, there is a 92% chance they're eating more than 1,800 calories per day. Okay? Which sounds pretty plausible. Okay? We were at a health food place when I was in LA, and a healthy chicken wrap, healthy, supposed to be healthy, was 1,200 calories. That was just a lunch. So can you imagine how much you probably are eating on a daily basis? Okay, now that was healthy. So let's look at B. Find the probability that a randomly selected stranger consumes fewer than 1,500 calories per day. Okay. Well, once again, drawing my picture. Not being perfect, I don't care. I would think 1,500 to be roughly right about here. Maybe, I don't know, it might be closer, I don't know. All I know is I know that I'm gonna be shading to the right or to the left. Exactly, now I'm looking at to the left. So I know this is going off to negative infinity, and my upper bound is going to be what?
1,500.
Very good. And then once again, when you go back in your calculator, you just pop in all the same information using the same mean they've given us, using the same standard deviation, and you should get probably a kind of weird number for you if you haven't seen it before. You're rounding to 4 decimal places, so what's it going to be?
Zero, 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 eight.
Very good. 0.0008. That negative, remember negative in your scientific notation says the decimal goes that direction. Okay, so what's the chances? If I asked you, are you gonna give me 0.008 conceptually, would you tell a friend that? No, what are you gonna tell them? There's almost no chance. That's exactly how it is. There's almost no chance that someone is eating less than 1,500 calories per day. You know? There you go. The freshman 15 is a common occurrence. For a freshman to put on 15 pounds in one semester, they would have to consume between 2,100 and 2,600 calories per day. Find the probability that a randomly chosen freshman would consume this many calories. Okay, so let's just come right here. That to me, personally speaking, it sounds like it's bounded. So I come in here, once again, I draw my graph. I know I've got 2050 here. I would think 21 would be roughly right about here. 26 could be right there. I'm looking for that. So am I going off to infinities anywhere? No, I am bounded between 2,100 and 2,600 calories. Once again, using your calculator, yes, could you use your table? Yeah, but now you're gonna have to standardize that 2,100, find the z-score for it, find the z-score for 2,600, okay? And then go look on your graph, which means you're also gonna have to take the 2,600 and subtract the 2,100 once you find those z-scores, respectively. Or you bound this in on your calculator, and you are going to get 0.3867. So some poor little high school student comes up to me and says, Professor Clark, I really don't want to gain weight. What are my odds? You have a 40% chance of gaining 15 pounds this semester. Not eating in our cafeteria because the food sucks. But there you go. And I have an idea. And 2,100 calories is not hard to eat. Okay, trust me, I know. That's how the homework's gonna go. Let's do one more, then I'll let y'all go early. You can kind of start your spring break early, but let's do one more. This one, notice there is a caveat to it. Look at it carefully. What is the in there?
Variance.
Variance. I told you how to do anything with variance. What do you gotta do with it? Square root it. Now, here's what's nice. Your calculator will still do it for you. Your calculator will still do formulas inside of something. Now, this one does give us a very nice square root. Okay, the square root of 40,000 is 200. Okay, but let's draw our picture and I'll show you what you can put in your calculator very easily. The weights of steers in a herd are distributed normally. That is important. Okay, the variance is 40,000 and the mean steer weight is 1,100 pounds. Find the probability that the weight of a randomly selected steer is between 1,000 and 1,520. Notice the word between tells me what? Yeah, look at that. That's going to be my lower. This right here is going to be my upper. I still would suggest drawing a picture just to make sure you know you're seeing what you're seeing. So we come in here, we put lower. We put upper. We've got a mean. And then we got a standard deviation. Okay, the mean is 1,100. The lower is 1,000. Upper is 1,520. Now, in your standard deviation, you can do this. You can come here and go, you can put the square root of 40,000 if you wanted to in your calculator. It'll work it out for you that way. Or take the square root separately and you would get 200. Doesn't matter, either way, you're gonna get the same answer. And what do we get?
98.21.
0 point what?
98.21.
That tells you what?
The
Probability of the weight being in between 1,000
Of what?
steer weight.
Right.
I have those numbers on, but I got a different answer.
Let me see. I have not checked it. Well, let me put it in my calculator. Never just trust people. Got 1,000 here, got 1,620. A mean of 1,100. Check your calculations.
I'll put on.
Oh, bro, messing us all up. Things happen, you got 0.6736. That better? Very good. What that is saying, now mind you, hear me, because you're gonna wanna know how to conceptualize this on a test and answer my why question when I ask them a lot. Okay? When I ask you a question, go, okay, what does this mean? You can say, hey, out of a population, because we're dealing with population still, out of a population of herd, I'm gonna randomly go out there and pick a cattle. Because maybe me and my wife, we wanna invest in a cattle so we have meat for a whole year. What are the odds that the cow that I pick is between this and this weight? That's my exact odds for that right there, because we're dealing with an exact population we know about. Okay, it's not saying we took a sample of something, it's saying we know all this. So that's my odds that we've just calculated of actually getting that kind of steer. So if I want one that's larger, then I'd have to calculate that. But if that's kind of the area that I'm looking for, then there we go. So this homework's pretty straightforward and simple, as you can tell. If you don't want homework over the spring break, because this is due the Sunday during spring break, you don't want homework during spring break, get it done now. Okay, other than that, I will see y'all when y'all get back.